Hello guys, welcome back to our channel, and in this video I will teach you how we can graph distance versus time and make the distance time graphs, and then displacement versus time graph, and then we have to compare the two of them. So at first you might think that they're just the same. Well, they are not. As displacement is a vector quantity, so this here is a vector quantity while distance is a scalar quantity. Okay, distance has something to do with the total length of the path traveled, while displacement has something to do only or is concerned only with the distance between the uh, final and initial position, and that must be a straight line that connects the initial and final position. So, if you want to learn more about distance and displacement, I recommend that you go back to the previous video wherein we discussed and we were able to derive and define motion in one dimension, and then we also have uh, derived the formula that has something to do and that can describe motion in one dimension, which are right here. And if you want to get the slides are in our Patreon account. So visit that and become one of our patrons. And I'm sure that you will not regret this because this formula or these slides are carefully prepared so that they, as much as possible, will be error free. So afterwards, after this video, we'll help you how to solve for problems that has something to do with motion in one dimension. So be sure to always subscribe to our channel and always click the notification bell to get updated whenever we post contents like this. So let's go back to our presentation and try to know what are the things we need to learn so that we can graph. Okay, so when we say graph, has something to do with the Cartesian coordinate plane, and when graphing, I highly recommend GeoGebra so that you can graph the equation or the points that you want to graph, and you can actually print it. So I'm gonna put the links down below so that you can download GeoGebra, or you can go ahead and type GeoGebra in Google so that you can download the app. Okay, you can sign in for free and then you can download the app if you wanted to. So let's say for example I have an equation right here, says 2x plus 3. So in an instant it can be plot there. So you have a lot of choices, and we are going to use this capability so that we can graph the points we wanted to. Alright, so let's go. So here is our target. So to answer the essential question, how our speed, velocity, and acceleration can be interpreted with the use of graphs. So in the previous video, as I've mentioned, we have described and differentiate speed from velocity and velocity from acceleration. Alright, so should be able to understand how to tell the difference between speed and velocity. Alright, so with the use of graphs. Alright, so conceptually we know um, what they are, but right now how do they look like when we graph them. So we will know what type of motion, what happened to the object, okay, when we see the graph. Did it accelerate? Did it stop? Okay, so we can get more information about it using graphs. And then you should be able to understand the difference between, well, I've read that already. And maybe, as I've told you, we are going to do some problem solving. So I can actually cut this out because this is not what we want right now. So, well, we'll start with distance and time graph. We have the x and y axes. Okay, so the x-axis will always contain the variable time or the values of time. Okay, and then the y-axis may contain the distance, the displacement, the velocity, the acceleration, and the speed. But the information along the x-axis, just like here, will not change. It will always be the time. Okay, so this is the specification. As I've mentioned, the time is always plotted on the x-axis. So I think I can cut that. Maybe I can. Okay, and then copy this. Then yeah, so that we can properly show things. All right. So and then distance is plotted on the y-axis. Okay, not only distance but um, or velocity. All right. Yep, velocity. So distance, velocity, or sometimes you plot the displacement right there. It's possible to do so. Yep. And then um, when we do it, there will be a different graph that will arise. So let me just save that. All right. So if an object is not moving, okay, but time is moving or time is flowing, okay, time will not stop. So it's like forward flow of time. Okay, so time passes by, so the value along the x-axis increases, but the value of distance does not change. So you will see a flat line or a horizontal line which is parallel to the x-axis, and this means that there is no motion. Okay, so if an object is not moving, a horizontal line is shown on the distance time graph. So time is increasing to the right, but its distance does not change. So it's not moving. We say that it is at rest, and there is a horizontal line that is parallel to the x-axis. All right, so I hope you get that. And then, what's this? Yeah, okay. We can enlarge it a bit so we can read it. Okay. So now if you see a graph like this, so if an object is moving at a constant speed, so there it is, a constant speed. Okay, so the constant speed or constant rate of motion is like the slope of the line. It means that um, it has the same increase in distance in a given time. Okay, so the time is increasing to the right and the distance is constantly increasing with time. So the object moves at a constant speed and you see straight lines. But right now, it's not parallel to neither x and y axis. It's not parallel to the time axis. It's not parallel to the distance axis, but there is a slope. The slope of the line is equivalent to the constant speed. So if we see this, meaning to say that the object is moving with a constant velocity. So next is we can compare the graph of motion of two objects. So if there are two moving objects right here, both lines in the graph show each object move the same distance, but there is a steeper dash line. Okay, so the steeper dash line got there before the other. So what does it mean? So the steeper line means that the object is that motion is much faster. Okay, because it involves less time to get to the same point. Okay, So a steeper line indicates that larger distance to move in a given time. In other words, it has higher speeds. Okay? So both lines are straight, so both speeds are constant. All right. So if you're asked what can you say about the graph, the distance time graph of the two objects? Okay. So the steeper ones are faster compared to the less steep ones. Then they have the same distance traveled because they are at the same coordinates with respect to distance. So we can graph that. Let's say, for example, I'm gonna open up my GeoGebra again, and then you just have to click that, and then let's say there are 2 points here. Okay. So right here is our x-axis, y-axis. So this is the distance. Okay. So meaning to say it traveled 6 meters within 2 seconds. Okay. Let's say for example the time is in seconds. It's measured in seconds. All right. So now another object. All right. Goes to where point A is, but this time it takes her 9 seconds. Okay, so if you graph it from the origin, okay, so let's say we graph it from the origin, and then we connect a line segment or a line passing this point. Okay, there we go. Then another line. So we see a big difference. Now we can calculate for the slope. Whoa, whoa. Yeah, of the two lines. Okay, and the slope of the two lines will give us the difference in speed. Okay, we will see that the steeper line is faster or has a greater slope, and then this one has lower slope, and then it means that it is slower. So how can we solve for the velocity given this graph or the speed of the objects? All right, so I will now use paint to show you how it is done. May take a while, but don't worry, we'll get there. All right, so I have now the paint here, and well, the speed is equivalent to the slope. Is equivalent to speed. All right. So when we get the slope m, those of you who understand algebra, that's m for slope, is equivalent to the change in the y-axis, okay, delta y all over delta x. All right, so m now here is the change in the y-axis, which is y sub 2 minus y sub 1 all over, since we have the time in the x-axis, that is t sub 2 minus t sub 1. All right, so continuing, so we can substitute the values that we have for the motion of the object or the speed of object number 1. Okay, so the y-axis, all right, is right here. So that's 2 and 6. All right, so y sub 2 is equivalent to 6. So you can see it here. You can see the coordinates of point A here, and this will be our y sub 2. Okay, so we get that, and then we type it here or write it in our paint. That is 6. Okay, so it left the original position or the starting position 0 and 0, so y sub 1 is 0. And then t sub 2, it gets to point A within 2 seconds. So 2 and then started from 0. So that's actually 3. And then if it is in meters, so 6 meters all over 2 seconds. So the unit is meters per second. So we can say that the speed of the object 1 is 3 meters per second. Okay, so how about object 2? Now we compare and do the same procedure. So m sub 2, or let's say, yeah, m sub 2, or the slope of the second line, or this is equivalent to the speed of the object, okay, is y sub 2. So it moved from 0 to the same position, 6, okay, minus 0, and that's 9, okay, seconds, in 9 seconds. So that's 6 over 9, and that is, you get the, we divided both sides by 3, because that's common to both. Okay, so that's 2/3. So that is 0.66 meters per second. So if we're going to compare, so the other one is 3 meters per second. So this one is greater than, or if you're going to compare versus 0.66 meters per second, you will know that we have greater speed. Okay, so this proves that the steeper the line, the larger will be the, uh, or the faster the movement is. Okay, so there we go. So I hope you learned that. Then moving forward, we go back to our slides here. All right. So now it's a little bit different. So I will cut the video here, and I will just name this distance time graph.